Good day everybody, this is a beautiful question. Foremost, let me draw the figure. So we got a circle and in the circle we've been given the diameter. The diameter is given. So let me take the diameter as AB. AB is 6 units. And then we've been given this information also. So let me take this point as O and let me take this point as say some C. Now BOC is given to be as 120 degrees, angle BOC, and the figure is hitting this point, or I should say there is a connectivity like this, and AOC is a triangle, and we are expected to find the area of this region, of the shaded region. So what is the shaded region here? This is the shaded region we are looking for. And how are we going to get that? You can pause the video and work the solution, and then you can check the solution which I would be extrapolating. Okay, so having mentioned that, I hope you got the solution. So foremost, what are the observations that I see here? I see that AOC is a triangle and AB is equal to 6, so AO is going to be 3 units and OB is also going to be 3 units. Now to get the area of the shaded region, what we have to do is we have to calculate two things: area of the sector AOC. From the area of the sector AOC, we have to subtract the area of the triangle AOC. Now what we have to do is we will have to get the area of the sector and the area of the triangle. Now area of the sector is easy. Why? Because BOC is 120. So if BOC is 120, this is going to be 60 degrees, right? So area of the sector AOC is equal to theta over 360 multiplied with pi r squared. My theta is 60 degrees divided by 360 times pi r squared is 3 squared. So 6 divides here 6 times and you got 9 pi divided by 6. This is the area of the sector. Now having got the area of the sector, we need to get the area of the triangle. Now we know this side, right? We know this is 3 units, this is also 3 units, but we need to get this side. So what is this side? AC is a chord. AC is a chord created by AO and CO, right? This is a very important point. Now what is the length of the chord? Formula: length of the chord is given by 2 times R sine of theta divided by 2. So if I want to get the length of AC, AC is going to be 2 times, my R is 3 units, sine of theta. The angle between the radius is 60 divided by 2. So 2 divides here 60 30 times. So this is going to be 6 times sine 30. Sine 30 is 1 over 2. 2 divides 6 3 times. So 3 units is the length of AC. So apparently all the 3 sides are equal, and you might be wondering, wow, the angle is 60 degrees. We could have outrightly said it is an equilateral triangle. Well, it doesn't work out like that always, right? So in this case it has worked out. But what if the angles are different or the distributions are different? So we need to ensure that we are catering to all differentiations, right? So we have got the side, or I should say the chord AC. Now, having obtained the chord, it's easy for us to find out the area, right? So the area of the triangle can easily be obtained. So in this case, how are we going to obtain the area of triangle AOC? What is the formula can we utilize here? Now, what we can do here is we can utilize the Heron's formula. If we were to utilize the Heron's formula, the formula is going to be square root of s into s minus a times s minus b times s minus c. So that would be the formula, where s is equal to a plus b plus c divided by 2. You can utilize that, or you can drop a perpendicular from C to AO. Now if you were to drop a perpendicular from C, this is going to be making 90 degrees, right? Now in this case we will have to apply the Pythagoras and we will have to extract, but apparently for that we again need to know the, say for example if this point is D, then we again need to know what is the size of DO or OD. So that again stretches the problem. So instead of getting the problem stretched, what I wish to do is I would like to apply the Heron's formula. So if I were to apply the Heron's formula, I will get the following. Now you can clearly see that this situation can arise, or this situation can be given as another problem, right? So they can easily ask us to find the area of this particular triangle. Of course I will show this calculation, or I would say show this problem in the subsequent videos. So for now, let me just focus on obtaining the area of the shaded region. So for that we need to obtain the area of the triangle. As I mentioned to you, all the 3 sides are given, or we have extracted the 3 sides, and we are just going to apply the Heron's formula. Since A is 3, B is 3, C is 3, this is going to be 6 positive 9 positive 3, which is 9 divided by 2. So let me keep it as 9 divided by 2. So this is equal to root of 9 over 2 times 9 over 2 minus 3, 9 over 2 minus 3, 9 over 2 minus 3. So this is equal to root of 9 over 2. LCM is 2, so this is going to be 6. From 9 you take away 6, you get 3 over 2. you get the same value, 3 over 2, 3 over 2. So this is equal to 3 3s are 9, you get a 9 there, and then you have a 9. I'm not going to do anything with the 3, so just place the 3. Now you have 2 2s are 4, you got a 4 there, and 2 2s are 4. Now why did I do that? Because of evaluating the square root. Now this is going to give me a 9, this is going to give me a root 3, now this is going to give me a 4, right? 4 squared, root, you take the root, you get just 4. So 9 times root 3 divided by 4, this is the area of AOC. So coming back to the shaded region, therefore area of shaded region. So what is the shaded region? Area of the sector, right, which is equal to 9 pi divided by 6 negative area of triangle AOC, which is obtained as 9 into root of 3 divided by 4. I can take 9 out and I can take 2 out. This is going to be pi over 3 minus root of 3 divided by, since I've taken 2 out, this is going to be 2 there. So if you were to take the LCM as 6, this would be 2 pi negative 3 times root of 3 divided, or I should say multiplied by 9 over 2. If you want, you can reduce this. 3 divides here 3 times, 3 divides here 2 times, and you can rewrite this as 3 times of 2 pi negative 3 times of root of 3 divided by 4 square units. So this is the area of the shaded region. This is a lovely question. Why do I say it's a lovely question? See the number of concepts we are utilizing. The most important concept is to find the length of the chord, and that is the formula I have shared with you. And the next important concept is calculating the area of the sector. Of course, area of the triangle is straightforward. So having mentioned to you this, I stop here. This is a light place for us to move on to the next lesson. Thank you, everybody.